Hello students, how are you? In the last video, I didn't tell you about the southwest monsoon approaches the Indian landmass in two branches. The first branch is the Arabian Sea branch, the second branch is the Bay of Bengal branch. Like this. Let me show you. So the first branch is approaching in this way, and the second goes like this. Because MLPT is here, it will approach from two sides. Now, what happened here is this branch bifurcates further into two branches. This Bay of Bengal branch bifurcates into the two further branches. One is going towards the northeast India and second going towards the Bihar, UP. So this wind going towards the Bihar, UP is also known as the Purva winds. Now, as we know that, now first let me clean it. As we know that we have Himalaya here. Okay, we have Himalaya here, which turn this Himalaya turn to the south in the northeast India like this. Okay, now what happens here is this Bay of Bengal branch, the first branch go towards the northeast India. Now here it faces the funnel effect. These are the mountains. When the wind go like this, so due to the it gets struck into the funnel of mountain, and due to the funnel effect this wind will rise, leads to rainfall, again rise, leads to rainfall, again rise, leads to rainfall. Due to this funnel effect of mountains, the wind get trapped here and leading to orographic rainfall again and again in during the monsoon season in India. And that's why in the Cherrapunji, in the Mawsin Ram, there is a recorded rainfall annually in India, or the highest rainfall in India throughout the year. Now we'll talk about the another branch which goes like this. This is also known as the Purva branch. Often a question is asked that the Purvaya decides the culture of Bihar, the culture of UP. How it is so? So I can give you the hint. You can derive the information from there. So if there is a Purvaya wind during the monsoon season, it brings moisture from the Bay of Bengal and drops it to the Bihar and UP. There is a song called Savan Ka Mahina Purvaya something, है ना? So this is also a part of culture. They express their culture in these songs. Kurta they wear, the cotton production. Okay, due to high rainfall, cotton production is possible. The rice production is possible. These all things, what they eat, what kind of culture they follow, you have to tell these things. Okay, like Bhojpuri culture you can elaborate, which is also related to the Purvaya. So in this way you can approach these types of questions. Now, coming to the main topic, which is the Western disturbance that we'll discuss today. Okay, I explained you this Bay of Bengal branch because I thought it is important. Now, we'll discuss the Western disturbance. What happens is Western disturbance. What is Western disturbance? In India, there is a rainfall in the northwest India, which is due to the Western disturbance. It is an extratropical storm that originates in the Mediterranean region. Okay, this extratropical storm, again, it is a storm, it is a low pressure system. Okay, it originates in the Mediterranean region that brings sudden winter rain to the northwestern part of Indian subcontinent. So, being a low pressure system, this is Mediterranean. Being a low pressure system, the it leads to the rising winds. These rising winds, okay, these rising winds will go to the tropopause where they encounter the subtropical westerly jet stream that we discussed in our last video. The subtropical westerly jet stream we discussed in the monsoon video, its influence on the Indian monsoon. Okay, in the last video I mistakenly used the word subtropical easterly jet stream. It is not easterly, it is westerly jet stream. Okay, so note that they travel these extratropical storm, they encounter the subtropical westerly jet stream as it flows like this. When the ITCZ shift to the south in winters, this these subtropical westerly jet stream encounter Himalayas and Tibet. These subtropical westerly jet stream, they encounter the Himalaya and Tibet, and due to these physical obstruction, they bifurcated into the northern and the southern branch. This is our Himalaya, and our north subtropical northwesterly jet stream. Okay, it goes like this from India. This is the southern branch, this is northern branch. Now, these the extra tropical storm get embedded within the subtropical westerly jet stream and travel from west to east. Okay, what happens here is at the Mediterranean there is a low pressure system which leads to rising air currents which get embedded within the subtropical westerly jet stream and travel from west to east towards the northwest India. Okay, now while traveling, it also picks up moisture from Caspian Sea. This is, let me show you. This is Caspian Sea. This is Caspian Sea. Okay, it picks up moisture from Caspian Sea and Persian Gulf. This is Persian Gulf. It, so it picks up moisture from Caspian Sea and Persian Gulf and drops it to the northwest India, leading to winter rainfall in India. It is important for, note that, it is important for development of rabi crop like wheat in the northern India. Okay, this was the concept. Like due to western disturbance, we have the winter rainfall in northwest India. For example, Delhi. This was the thing. If you didn't understand the bifurcation of subtropical westerly jet stream, I'll again explain it to you. The subtropical westerly jet stream is bifurcated into the northern and southern branch due to the physical obstruction by Himalayas and the Tibetan Plateau. The Himalaya and the Tibetan Plateau in winters. Why in winters? Because ITCZ shifts to the south in winters, and therefore the subtropical westerly jet stream do. So in summers it is like this, but in winters it moves to the south and bifurcates into the two branches. It bifurcates into the two branches. The first branch is this, and due to the physical obstruction by Himalaya and Tibetan Plateau, the second branch is this. This is the northern branch, this is the southern branch. In summers, the ITCZ shift ups towards the India, towards north. It shift towards the north in the month of June. Okay. Due to which again these subtropical westerly jet stream shift to north and became like this. Okay, now I think the concept is clear, and this subtropical westerly jet stream is at tropopause between the Hadley and Ferrel cell. I explained it to you in my last video, you can watch. Thank you.